Hi students, this is Neeraj Bansal. In the last video, we have talked about how to make the equations of the plane. Now today we are going to first talk about how to find the distance of a point from a plane. Right? So let's start. So distance of point from a plane. Like when we were doing lines, we have said that let's say this is the line and we want to find the distance, the shortest distance between the line and this. So this length, we have found the perpendicular distance and this was my answer. Same way, if let's say this is the plane and this is a point, I want to find the minimum distance of point, this point, let's call this point as N, or rather we call it P. And then we are saying that this is the end, foot of the perpendicular. So how will we find this distance, right? Which will be the shortest distance. So let's take one question, then we'll be able to understand. So let's take this question from here. Right. So what this question is saying, suppose N is the foot of the normal from A to the plane this. So I have this plane and this is a point A, which is 2, -1 and 3. And this is the equation of the plane is x minus y plus 2z is equal to 27. So let's say this is a general point on the plane. Right. So if I'm saying this is my equation of the plane, so normal vector is 1, -1 and 2. Got it? So this is my normal vector. Is this clear? Now I have found the normal vector. Now what I need to do, this is my normal vector. So let's say I want to find the equation of this line, right? And then wherever they match with each other, then we'll say that this is the point, right? So let's do it. So this is my normal vector. So this will be the, I can say the direction of the line, because the direction of the normal vector is this. So I have a point on the line 2, -1 and 3, and this is the direction vector of the line. So the equation of the line will become vector r is equal to vector a plus lambda vector b. So vector a will be the point which is 2, -1, 3 plus lambda times 1, -1, 2, right? So this is the equation of the line, right? Now what I'm trying to say, I want to find this point, this, let's call this point as N. This N point is lying on the line as well in the plane. So we have to equate the equation. So if I'll say x is equal to 2 plus lambda, y is equal to -1 minus lambda, and z is equal to 3 plus 2 lambda. So let me put this in the equation of the plane. So this becomes 2 plus lambda negative of -1 negative lambda plus 2 times 3 plus 2 lambda is equal to 27. So which will give me 2 plus lambda plus 1 plus lambda plus 6 plus 4 lambda is equal to 27. So this will give me how much? 4, 1, 2, 3. So that means 4, 5, 6. 6 lambda plus 3, 6, 9 is equal to 27. So this will give me 6 lambda is equal to 18. So lambda is equal to 3. Perfect. So that means if I'll substitute 3 in this, I will get the N. So let's substitute it here. So now it is N is equal to 2 plus lambda. So 2 plus 3 is 5. Right? -1, -3, -4. Right? So 6 plus 3, 9. So this is my n. Got it? Vector n. And I have got my vector A as 2, negative 1, 3. 2, negative 1, 3. Right. So now I can find vector an as vector n minus vector a, which will be 5 minus 4, 9, minus 2 plus 1 minus 3, which will give me 5 minus 2, 3, minus 3, and then 9 minus 3 is 6. So I want to, this is my vector an. I want to find the magnitude of it. So how I'll find the magnitude? Under root of 3 squared plus 3 squared plus 6 squared, which will be 9 plus 9 plus 36. So what it will give me? 18 plus 36, 54. So under root 54 is my answer. So distance of this point from a plane is root 54. Got it? So root 54 units is the distance. So this is how you do it. But in IB, you can use one formula which is a direct formula. Got it? I'll explain you what that formula is. But if you use that formula, the question becomes easier. So my formula is D. D means distance, which is root 54, is equal to AX1 plus B AX plus BY plus CZ plus D over under root of A squared plus B squared plus C squared. Here, XYZ is the point, like in this case A, and your vector n is equal to ABC. What is this ABC? ABC is your normal vector, which is the normal vector of the plane. We'll do one more question so that this will become clear to you how we have got it, right? So let's take this question. Right. So basically what this question is saying, that let's say these are the two planes, right? Let's call this plane as this. So question is x plus y plus 2z is equal to 4, and 2x plus 2y plus 4z plus 11 is equal to 0 is the equation of this plane. Now I want to find the minimum distance between the plane. So minimum distance between the two planes is the perpendicular distance. So what I can do is I can find this point. This is any random point, right? And when I find this point, then it will become something like the distance of point from a plane. So I'll find a plane, random point. I can use any point. So I can put x as 0, y as 0, z as 2. So let me put it. So x plus y plus 2z is equal to 4. Now I'm taking x as 0, y as 0, and 2 times 2 is equal to. Why I have taken this? Because left hand side is equal to right hand side. That's why I have taken this or these coordinates. So the coordinates of this point becomes, let's say my A becomes 0, 0, 2. Perfect. And now I have this point. So I will, this time I'm straight away using the formula under root of AX plus BY plus CZ plus D over under root of a squared plus b squared plus c squared, right? So magnitude of what is my a in this? A is the normal vector. So my normal vector in this is 2, 2, 4, right? So this becomes 2 times 0 plus 2 times 0 plus 4 times z is 2 plus d, which is 11, under root of 2 squared plus 2 squared plus 4 squared, right? So this gives me 0 plus 0 plus 8 plus 11 over under root of 4 plus 4 plus 16, which will give me 19 over under root of 24. So this is my distance. How easy it is, right? So this formula is not given in the formula booklet. Got it? So you have to understand it. Perfect. Now my next topic is angle between plane and a line and angle between two planes, right? So when we were doing the two lines, right? If I want to find the angle between two lines, the previous video we have done, we have to find the dot product of the vectors. Vector b1 dot vector b2 is equal to b1 b2 sine theta. Then I can make theta as a subject and find that. Same way here we will do, but just a little bit of trick you need to understand. Whenever you have an angle between line and a plane, then you have to use sine here. Why? I'll tell you. Let's say this is the plane and this is the line which is passing through the plane, and this is the direction vector of the plane. So angle between line and a plane is this theta, right? The angle between the line and the direction vector is this, but I want this angle. Got it? So which is 90 minus theta, right? This is vertically opposite angle. This angle is 90 degrees. So I want basically this angle theta. Theta dash, I want this theta dash, which is the angle between the line and the plane. So which is 90 minus theta. So you just remember this. Whenever you have to do the angle between the line and the plane, then you have to use this. Sine theta is equal to magnitude of vector b1 dot vector b2 over b1 times b2, or theta is equal to sine inverse b1 dot b2 over b1 times b2. What is b1 and b2? The direction vector of the line and the plane. Let's do the question and then you will be able to understand how it is done. Let's take this. So this is my equation of the plane. So I'll take equation of plane as x plus 2y minus z is equal to 8. And then I have x equal to 0 plus t, y is equal to 1 minus t, and z is equal to p plus 2t. So this I can find as vector r is equal to 0, 1, 3 plus t times 1, negative 1, 2. So my direction vector is this. Clear? And the direction vector of the plane, that means vector b1 is equal to direction vector of the plane 1, 2, negative 1. and my vector b2 is 1, -1. So my answer will be sine inverse right, theta is equal to sine inverse magnitude of vector b1 dot vector b2 over, sorry, yeah, b1 times b. Got it? This means the magnitude of it, so that means sine inverse b1 is 1 times 1 plus 2 times -1 plus -1 times divide under root of 1 squared plus 2 squared plus 1 squared times under root of 1 squared plus 2 squared plus 1 squared, right? This will become sine inverse. This will become 1, -2, -2 over 1 square. That means 1 plus 4 plus 1. So sine inverse -4, -3. So 3 by 6. That means half. So sine inverse half. What is sine inverse half? That means this is the larger one. Half root by 2 is 30 degree. 30 degrees. Angle between the line and the plane is 30 degree. I hope this question is pretty much clear to you, right? Angle between line, plane, 30 degree. But when you have to find the angle between two planes, right, then you have to use only cos. Just remember this. When you have to find, why I'll tell you, let's say this is one plane and this is another plane. This is this and this is this. I want to find this angle, right? So when the angle is between uh, two heads, these are heads of the vectors or tails of the vectors, then the angle remains the same. So you have to find this angle. You simply take the dot, you simply take the dot product and then use cos to find it. We'll do one question, it will be more clear, right? Let's do it. So these are the two vectors, right? I want to find the angle between these two planes. So I just need to find vector b1, which is the normal vector of plane 1, 1, 1, -1, and vector b2, which is the direction vector of this plane. Please refer to my previous videos because I have made all the whole vectors topic in a series of videos. So if you watch the whole series, you will find vectors very easy. So 2, -1, 3. Got it? This is the direction vector of this plane. So theta is equal to cosine inverse vector b1 dot vector b2 over magnitude of vector b1 times magnitude of vector b2. So I'll do it here, right? So this is cosine inverse something. Cosine inverse, then you can take 1 times 2 2. 1 times minus 1, minus 1. Minus 1 times 3, minus 3. Under root of 1 square plus 1 square plus so root 3. Got it? Times 2 squared is 4 plus 1 plus 9, right? So cos inverse 2 divide root 3 times root 40. So when you will solve it, you will get the answer. You can do it over the calculator as well. Just let me open my calculator and then we'll be able to solve this as well on the calculator. Got it? So I'm saying again and again, please do watch my videos, not by making it forward. Just listen to, just do the things so that you can like see the whole video nicely. Got it? If you'll see the whole video nicely, then it will be easier for you. Got it? I think that will solve it later, but no problem. So basically, you can solve this, right? Perfect. Then let's move to the next thing. What is the next thing that is very, very important? You must, I have already taught you augmented matrices. What do we mean by augmented matrices? Augmented matrices you need to use if when you need to use the when you need to solve the simultaneous equations. It can be 2 simultaneous equations or it can be 3 linear equations, right? So you're already familiar with this. If you're not aware of this, go back to my video of augmented matrices and then you'll be able to do. Here I'll not tell you again how to solve the augmented matrices because it will take time. And anyhow, I have made a separate video on this topic. So what I'm going to teach you is how to analyze the solution. So basically, we know, let's say we have 3 planes. Obviously, these 3 planes will have 3 different equations. That means 3 simultaneous equations. I can have P possibilities, or rather 4 possibilities. If I have a unique solution, I can have infinitely many solutions. Or I can have no solution. So if I have unique solution, this means in unique solution, P planes are meeting at a point. P planes are touching at a point. In no solution, or rather first we'll talk about infinitely many solutions. There are 2 possibilities. Got it? What are those 2 possibilities? First possibility is the 3 planes are meeting in a line, right? Then we have the second thing is 3 planes are coinciding. There are different conditions for this. So first I'll discuss how to interpret the solutions. So we know no solution. First we'll talk about no solution. When I'm saying no solution, this means the situation is something like this. Obviously, you have to make this triangle of zeros as we have already discussed in our previous lecture. So if this When I'm making square, that means I can have any value here. So the matrices of coefficient for which you need to refer to that video. So this is the condition of unique solution. Right? Sorry, this is the condition for unique solution. Let's talk about the condition of no solution. So in case of no solution, you will have something like this. What this is saying is 0x plus 0y plus 0z is equal to something which is not possible. Hence, this is no solution. Then, as I've told you, there are two cases in the in case of infinitely many solutions. This first case. In this case, as we can see, the last row is all zeros. So these three planes will be meeting at a line. And then I can have is this kind of situation. Something like this. Right? That means two line of zeros. When we have two line of zeros, three planes are coinciding. Got it? You have to just remember this. You have to solve and then it will. Then you can find the solution. Perfect, right? So what I'm going to do, I'm going to show you one or two cases. I'll not solve the matrices. I'll directly tell you how to interpret, else the video will be longer. But yes, if you still find any doubts or you want to contact me, you can contact me on the number given below. Or very soon I'll be coming live on YouTube. Then we can do it. But for the time being, I'm just telling you how to interpret these things, right? Let's take this and this. Paste it. All right. So let's see what is happening over there. Solve the following system of linear equations. In each case, give a geometric interpretation of the system. So basically, what is happening is this is my row of, these are my three equations. These three equations are the equations of three planes, right? And these are also three equations of three planes. Now let's see what is happening in each of the two cases. These are the raw operations which are being done, which I've already explained you in that video of augmented math. So final result which I'm getting is this. Got it? So if I get something result like this, this is the triangle of zeros which we have got. And then here I have got this. So this is what, which is this case? This is the case of unique solution. Perfect. So when I've got the unique solution, so I can write 1z is equal to -1. So z is equal to -1. Then you can substitute the value of z here and then solve it. And then you can substitute the value of x, y, x and y and z in the upper situation and then solve. Got it? So this is your unique solution thing. Got it? Let's move to the next equation. What is happening over there? First, we need to again do these raw operations, and finally we've got this. So when we have got this answer, right? When we have got this answer, that means all the last row is all zeros, but we have only one row of zeros. So when we have only one row of zeros, that means the three planes are intersecting at a line, right? So three planes are intersecting at a line. And how to make the equation of this, you can just go through this and I'll explain you how it is. So basically what is happening, I can take, in this case, I have 0x plus 0y plus 0z is equal to 0, right? So I can have any value of z. Why only z? Why not x and y? Because here the x will have certain coefficient, here y is having certain coefficient, right? So I'll take z. If I take z, I can take z as t, because any value of z will give me the same solution. So I'm taking z as t, right? Then if you put this z as t in the previous row, you will get something in terms of you will get y as minus 1 by 3 plus t. And same way, when you place this y in the upper equation, you will get x something in the form of t, right? So you have got x, y, z in terms of t. So now what is happening? You have the solution x is equal to 7 by 3, y is equal to minus 1 by 3 plus t, and z is equal to t, which is the equation of a line. So that means these three planes will meet at a line. I hope this is clear. If you have any doubt, I'm asking again and again, please send me on the comment or contact me. Got it? Rest, in the next video we'll start with some other topic, and in the meantime please subscribe my channel.